With what seems to be the end of the bear market, or at least in the crypto world, there is a ton of opportunity for developers to start making money today. One of the best ways to go about this is freelancing, which is something that I do quite frequently. In this series, we're going to be going over a project that I created, which is an ERC20 token with an airdrop feature as well as a staking function. My name is Anthony with the Blockchain Dojo, where we turn you into a blockchain ninja. If you learned something new, please like and subscribe, and stay tuned for more content. Let's get started. In the first part of this series, we're going to be going over the ERC20 token, the special features that I implemented in there, as well as the airdrop contract. The next parts of the videos, in the next series of videos, we'll be going over the staking function or the staking smart contract, as well as all the tests and how they actually interact together. First, we're going to be going over the ERC20 token and how we actually implemented it. With standard smart contracts, we declared the license identifier as well as the pragma version. We imported in the ERC20 contracts for the ERC20 token from OpenZeppelin, as well as the safe ERC20 and the IERC20 interface. Next, what we did is we declared the ERC20 token, inheriting from the ERC20 smart contract. And then we're using the safe ERC20 tokens for ERC20. Next, what we do is we declare an owner of the smart contract. This owner is essentially going to be the admin who has control to mint and assign tokens to the locking contract, the staking contract, or the claiming contract. In this smart contract specifically, I implemented a live supply as the client wanted the token to specifically limit or cap out at 8 billion. As opposed to being able to mint infinitely. Also, what we have here is the constructor taking in the token name and the symbol, assigning the owner as the deployer of the contract, and then minting 2 billion tokens to the deployer of the smart contract, implementing the mint function that we wrote right here. Now, going over the minting function, as mentioned that there was a special requirement within this smart contract to ensure that it doesn't go over the live supply. So for this minting, the first thing we want to do is ensure that the person calling the minting function is in fact the owner. And then we require that the live supply plus the mint amount is going to be less than or equal to the max supply. So this keyword right here triggers that the current live circulating supply plus the amount we want to mint is going to be less than or equal to the total max supply. This is satisfying the requirement set forth by the client. From there, we increment the live supply by the amount that we're minting, and then we mint using the internal minting function from the ERC20 contract that it inherited from, and we mint to the message.sender and the amount. And of course, the message.sender is once again the owner. Up next, we have a special function called mint to address. Now, this is going to be used to specifically mint tokens directly to one of the addresses. Now, I implemented this function so that the client would be able to mint directly to the airdrop contract or the staking contract. But it does work so that you can mint directly to another user as well, even though that's not the intended process. Ultimately, it's at the discretion of the client who he wants to mint the tokens for. So similar to the mint function, we have the owner equals msg.sender to ensure that the owner is the message sender is the owner of the smart contract. Same live supply plus amount is less than the max supply. Same incrementation, and then the same minting, except instead of minting to the msg.sender, we're minting to the target that is taken in as a parameter of this function. Now, the burning function is going to be very similar to the minting function, except it's going to do the opposite. So what we want to do is we want to ensure that the live supply minus the amount is going to be greater than or equal to 0. You don't want to burn into the negatives, just wouldn't make sense, could cause overflow or underflow arithmetic issues. Next, you want to ensure that the balance of the message.sender is going to be less than or equal to the amount, ensuring that the message.sender can't burn more tokens than they actually have. We then decrement the live supply by the amount, and then we burn the tokens from the message.sender and the amount passed in as a parameter of this function. The second part of this smart contract is the claim tokens or the airdrop function. So similar to the ERC20 token, we declared the identifier, the version, we inherited from the, we're also importing the interface for the IERC20 token. We declared the claim tokens contract, which is just another name for the airdrop. We declared the owner, and then we have the reward token. Now this reward token is going to be set as the token passed in from this address here. And it will be this token that we are actually passing in the constructor, this token's address. From there, we have a whitelist struct. Now this whitelist struct takes in a target address and then an amount to mint towards that, or to send to that specific target. We then have an array of the whitelist addresses, and then we have an event of token claimed and bulk token claimed. Now in this airdrop, there are two functions for claiming contracts. So what you can actually do is send tokens out to a bulk send to all the whitelist addresses, or an uploaded input of addresses, or you can send tokens to one specific user. Tokens claimed is sending it to one specific user, and bulk token claim is sending it out to the group. From there, we have an add to whitelist function, which takes in two parameters, the new target and the claim amount or the whitelist amount that they earned. Same requirement that the owner has to, or the message sender has to be equal to the owner. We create a new whitelist struct, passing in the target address and the claim amount from the parameters, and then we push it to the whitelist array up top here. Now the claim tokens is going to be very similar to what I was just describing, where a user is able to set, or where the owner is going to send out tokens to the whole array of whitelist addresses. So for this, what we do here is we have a total send amount, and where we're going to use a helper function to calculate the total amount of reward tokens that need to be sent. Then we require that the reward token balance of this address is going to be greater than or equal to the total send amount. We want to ensure that this address has enough tokens to satisfy the tokens transfer of the rewards token. From there, we loop over the whitelist and then send out the appropriate tokens. While this isn't the most gas efficient way, this was the requirement set forth by the client, as he wanted to be able to send out to everybody all at once. The claim tokens function is very similar to, the claim token function is very similar to the claim tokens, except this is where we send it to one single user, where we pass in the user's address and the amount, and then we do the same checks to ensure that the owner, or the message sender is the owner, and that the balance of this smart contract of the rewards tokens is greater than or equal to the amount looking to send. Then we transfer out the token amount. And then the last function we have here is a bulk send, which takes in a whitelist array of the specific structs, which can be uploaded via JSON. And then it iterates similar to the previous claim tokens. It iterates through the list of the uploaded array, and then transfers out the appropriate amount of tokens to the specific user. We definitely went over a lot of code there, but it's really ultimately pretty simple. It's a standard ERC20 contract, which has a few implementations put in to limit the total supply, as well as it's a pretty standard airdrop contract, which has a few ways to airdrop tokens, which you can store the whitelist within the contract itself, or you can upload an array of the whitelist and the amounts that you want to send in the JSON format, as well as we have a direct airdrop sending to one specific address and the amount of tokens you want to send. In the next video, we'll be going over the staking contract and how to actually implement the staking. If you learned something new, please like and subscribe, and stay tuned for the next video of this series.